All right, thanks, Kate. Hi, everyone. I'm Sarah Geyer. I am the new for 2022 program chair for Wild Ones Oak Opening. So I'm really happy to have joined. And before I give you Christina's bio, I just want to say that when I started working with the committee this past fall, we looked at a list of potential speakers, and Christina was on there that members had suggested, and immediately I was like, yes, Christina's awesome. So I've had the pleasure of working with Christina in my role as a water quality planner for TMACOG. So we worked together for several years, and I'm really excited to introduce her. So Christina is the Wetland Habitat Program Administrator for the Division of Wildlife at the Ohio Department of Natural Resources. She has 2 degrees in forestry and natural resource conservation management from the University of Kentucky. And then she's been working for ODNR since 2013. During that time, she's managed 19 H2Ohio grants worth over $14 million. Oh, that's just since 2019. So she's also assisting with wetland establishment on private property through the Water Quality Incentive Program. And that program is leveraging $6.8 million of H2Ohio funds with the Lake Erie Conservation Reserve Enhancement Program. This initiative is looking to add over 3,000 acres of wetland projects to the Lake Erie watershed. So welcome, Christina. Looking forward to hearing about all the work that you've been doing.
Yeah, excellent. Thank you all for having me. I hope I can live up to the expectations of this group for providing a quality talk this evening. So I will do the best that I can, but very much appreciate being able to join you all. And yes, I'm with the Ohio Department of Natural Resources, and I will go ahead and get started here. Okay. All right, so my presentation this evening, if you have not heard about H2Ohio, or you've seen, something pop up in the Toledo news, and you got a bunch of people standing around a wetland, and you've heard about the program, but maybe don't know exactly what it is, hopefully in my presentation this evening, I will help bring some of this additional detail to light, what it is, why it's important, and why it is so special for Ohio. All right. So this is roughly what my presentation is going to cover. First off, what is the H2Ohio program? Why is wetland restoration important for Northwest Ohio? What do we know about nutrient loading in the Western Lake Erie Basin? Knowing is part of the solution. And also, I'm going to walk you through some examples of H2Ohio wetland restoration projects. Okay, so big picture. We'll start with big picture first. H2Ohio came about. How did it come about? H2Ohio is Governor Mike DeWine's vision for really improving water quality across the state of Ohio. And H2Ohio is unlike any other program we've had before in Ohio government, because it links several different agencies together to utilize their unique skill sets to fix a common problem. So in this slide, we feature the Ohio Department of Agriculture, the Ohio Department of Natural Resources, as well as the Ohio Environmental Protection Agency. And all 3 of these agencies in our work is coordinated through the Ohio Lake Erie Commission. So H2Ohio is really neat. It just came about in July of 2019, where Governor Mike DeWine worked with the legislature to appropriate a significant amount of funding towards water quality initiatives. So the Ohio Department of Agriculture, they have their own pot of H2Ohio funds to specifically focus on nutrient reduction at the field management level. Ohio EPA also received funding to address failing septic systems and lead prevention in sensitive communities. But for today's talk, we're really going to focus on the Ohio Department of Natural Resources and the work we've done for restoring wetlands in Northwest Ohio. So first, here is a map showing all of our wetland projects generated from H2Ohio since 2019. I look at a map like this with all the dots, and I'm really happy about it. But this is also why I drink coffee, because a lot of these projects are mine. And there's a lot of work that goes into these projects. And H2Ohio is a program that we do not function at the pace of government. We are moving at light speed to restore wetlands as fast as possible. So I've had a hand on at least 19 of these different purple dots and green dots that are on here. So just to help break down this map a little bit, because it is really busy. So there is a pink outline here. This is the Maumee River watershed. There's a little yellow outline here. This roughly delineates the Sandusky River watershed through here. This whole space that's delineated with these yellow and purple lines, this is the watershed that drains into the Western Lake Erie Basin. And it's not a coincidence, given the water quality issues that persist in the Western Lake Erie Basin, that we have lots of wetland restoration projects taking place in this area. We've got wetland projects taking place along the coast. We've got wetland projects taking place along river floodplains, just all over. And then you may notice too, we've got these little green, or not green, but they're gray, these gray dots here scattered across the landscape. Those gray dots are all private lands, wetlands. So that was a landowner that came to ODNR and said, I've got this field that repeatedly floods. Let's piggyback on the Lake Erie Conservation Reserve Enhancement Program and put a wetland here. So we've got all kinds of projects, very busy map. And as we've had more success in the Western Lake Erie Basin in 2021, we really made an effort to branch out into other areas of the state. So we've got some projects in the Ohio River Basin, and we also have some projects out in Northeast covering more of the central Lake Erie Basin. So let's put some numbers to those dots. So in total, right now, this graphic, we have difficulty keeping it updated because we add new projects probably about every month, every 2 months. But right now, fresh, hot off the presses, as of the new year, we have 83 wetland grant projects. And all told, to make all this work happen at ODNR, we've had $89.6 million go out the door to make these wetland projects happen. And what's really neat is we're not just putting these projects out in the landscape, we are also taking the initiative of taking $4.3 million and allocating that to a research and monitoring program for all of these projects. So we actually have a contract with the LEARN Consortium, which is a group of scientists that are going out to a lot of these restored project sites and pulling soil samples and water samples to show that when we have made these investments, we're going to measure and make sure they worked and that we got the water quality improvement we hoped for. Of course, to make all this work happen too, I want to point out that we have got 43 nonprofit conservation partners helping us to do this work. So in the Western Lake Erie Basin, I have had the pleasure of leaning very heavily on some park districts, the Maumee Watershed Conservancy, as well as the Black Swamp Conservancy, which has done a spectacular job in getting these grants, managing them, and getting conservation implemented on the ground. Really spectacular organizations to work with. And when we're installing wetlands, the important thing to keep in mind is that we're not just trying to shoot for getting restored wetland acres. I mean, this figure here is pretty neat. The 11,000 699, that is the number of wetland acres that we have restored or we have under contract to get restored. So it's a huge amount of wetland restoration taking place in a time period of about only 3 years. And restoration at that pace is unprecedented. I don't know of any other state that has been restoring wetlands at the rate that we have. But what's neat is these wetlands and a lot of these projects, we're building wetlands, but those wetlands capture a watershed area. And so this 11,000 acres of wetlands is capturing about 98,000 acres of watershed. So we're putting a wetland in the landscape. It's taking on agricultural drainage. We are specifically choosing projects for those qualities. So we are really getting the most out of our investment. And I've got a nice example of a project that does exactly that towards the end of the talk that I'll share with you. For these wetland restorations, not only are they being put in to reduce nutrients and capture sediment, but oftentimes we can get some tangential benefits of these projects. A lot of these projects, it was private property that was purchased with H2Ohio funding or Clean Ohio funding. We've restored it and it can be a place open to the public. Or we've been able to put in wetland restorations that will help reduce sediment nutrients and also help threaten endangered species. So we had a project in Williams County where we were able to integrate some habitat and extra protections for the copper-bellied water snake, which is a federally threatened species in Ohio. And we've planted over 40,000 trees across a lot of these projects. And again, a lot of these statistics capture our H2Ohio grants, but we also have over 140 private landowners that we are working with and incentivizing them to put wetlands in the marginal areas of their fields. So in other words, if they've got a crop field that experiences regular flooding, that just isn't very productive, they've come to us and we've provided an incentive to help them and encourage them to put more wetlands on their landscape. Okay. So I had mentioned the Learn group before. We're making sure that we are accountable to all of these dollars that are going out the door. And we want to make sure we are getting the nutrient and sediment reduction that we're hoping to. So this slide, represents the Lake Erie Aquatic Research Network. That's the group we're working with to monitor all these projects. And these are a few of the organizations represented in the Learn network. So if you're familiar with looking at any of the Lake Erie harmful algal bloom reports or anything like that, the National Center for Water Quality Research, they have been monitoring the levels of nutrients flowing out the Maumee River watershed for decades, since 1974 to be exact. So we have their expertise involved. We also have expertise from Tom Bridgman and his group at the University of Toledo. Kent State, there's a really excellent wetland ecologist there that focuses specifically on nutrients and wetlands. We have insight from BGSU, Ohio Sea Grant, OSU, and Wright State University. Wright State's done a lot of research work on treatment trains, if anybody's ever heard of the treatment trains down by Grand Lake, St. Mary's. So we have a wealth of expertise helping to oversee these projects. And again, the goal of this is we're going to see if the project worked, or if it didn't work, what can we tweak different to make it more effective? All right, so why is all this wetland restoration work important for Ohio, and more specifically, why in the Western Lake Erie Basin? Well, restoring wetlands is very ecologically relevant for Northwest Ohio. So I'm sure, as many of you are already aware, much of this area used to be covered by the Great Black Swamp. And this was a formidable place. If you read historic articles about the Great Black Swamp, it was exceptionally wet. Even within the major confines of the Great Black Swamp, many Native Americans did not live there because this area was just so impossibly wet. When settlers were coming across Northwest Ohio to, put their mark on a piece of property and set up shop and start a home. They were lucky with a horse and wagon to traverse 1 mile per day in the Great Black Swamp because it was so incredibly wet. The horses would sink to their bellies in mud. So it was very difficult, very treacherous landscape. And we have been able, through the help of technology, to drain this landscape. And we have a very productive agricultural economy now. And the way we've been able to do that has been with subsurface drainage. So I'm from Kentucky originally. And when people were trying to explain drain tile to me, I didn't get it. Whenever if someone would say tile, I think, oh, it's like the tile you have in your bathroom on your wall or on your floor or something like that. But when we mean drainage tile, we're talking about this corrugated black plastic, and it's got little slits and little openings across all of this so that when it rains, the rainwater will percolate through this soil, hit this tile, and the tile, it's graded just slightly so that when it fills with water, the water will gravity feed out through the tile into the closest ditch. And so this is the whole network that's been implemented across the Northwest Ohio landscape that's opened up all this really incredible arable farmland. Plus, it makes the region a lot more livable. I love wetlands. We've restored a bunch of wetlands with H2Ohio, but I gotta say, I would not be thrilled to have my house in one and be wading around in water all the time. So this technology, it's really had value to us. And just for context, Northwest Ohio is certainly one of the most intensively drained landscapes in the lower 48 states. So this is a graphic that's taken from the agricultural census. It's an older census, but it gets the point across nonetheless. So this area of Ohio, Northwest Ohio, that's bright red, those are acres in Northwest Ohio that are 60 to 100% tile drained. So we have lots of subsurface drainage in Northwest Ohio, and a lot of that has to do with the Great Black Swamp. And the Great Black Swamp was here in Northwest Ohio because of our region's glaciation history, thus making our region as flat as a pancake. So I touch on subsurface tile because it has really important implications for how we live our lives every day, but it also has a very important role to play in water quality. So a few years ago, there was an initiative through the federal government and the states to try to answer this question. How many nutrients and sediment flow through our subsurface drainage network in Northwest Ohio? And this was the paper that made a really good attempt to answer this question. Kevin King and others set up this big edge of field research study. So they looked at 38 different fields across Northwest Ohio, and they had this very sophisticated monitoring system that could monitor the surface runoff from farm fields and estimate the amount of sediment and nutrients flowing from surface runoff. And then they also had a gauging system on the drainage tile network and looking at the volume of water that moved through that drainage tile network, as well as the amount of nutrients that it carried. So it's a pretty complete picture from a field scale, farm field scale, what was moving on the surface of the field, what was moving in the tile. And this was a really important paper. And I've got a little bit of highlighted information here in the abstract. And what we learned was that the subsurface discharge from the farm fields that were measured in this study accounted for about 80% of the annual discharge of water volume. So when a field's draining, 80% of the water is coming out the tile, not flowing over the surface. And in that water, that accounted for about 70% of the annual dissolved reactive phosphorus load. So what that means is we're moving a lot of phosphorus through subsurface drainage tile. And phosphorus is the key nutrient that feeds harmful algal blooms in the Western Lake Erie Basin, more so than nitrogen. Nitrogen tends to have more of an effect in saltwater ecosystems like the Gulf of Mexico. So for the purposes of this, it really points to, okay, if we want to address nutrient loading problems, we really need to focus on the water that's flowing through our subsurface drainage network. And that doesn't necessarily mean that tile is bad. I mean, tile is really good. This just shows we need to adapt and really focus on trying to implement practices that can capture the phosphorus we're losing through our subsurface tile drainage network. Also, just some other context for you. Drainage has had an impact on the landscape, and the amount of water we move and we drain from the landscape, it has a measurable impact in our rivers as well as other large aquatic systems. So I'll show you a little bit of that here. So I'm sure we've all spent some time with the Maumee River, and what's really handy for the Maumee River, as well as a lot of other large river systems in the United States, oftentimes, because of the flooding history we have, these rivers have measured water levels that you can conveniently look up from the United States Geological Survey. So the United States Geological Survey happens to have a gauge measuring the discharge from the Maumee River right in Waterville. So if you cross the Waterville Bridge right by, where the Lucas County, Wood County line is, they just went and redid that bridge. You may notice there's like a little outhouse structure on the Lucas County side of the Waterville Bridge. And that is the gauging station that USGS has there. And that gauging station's been there since about 1925. So we've got a data set of Maumee River volumes that cover about the last century. So that's this axis down here in the X, or our X-axis, the bottom, that's our years. And then we have our Y-axis, which is cubic discharge feet per second. So a cubic foot, 1 cubic foot is about 7 gallons. To help, put it in terms that are a little bit more understandable, because trying to comprehend a cubic foot's a little weird. But what we're going to do, we're going to take a trip through time and see how the water volume discharge, just the discharge in the river, has changed as our drainage technology has improved, as time has gone on, as we've seen changes in rainfall events. And this is what we have. So from about the 1920s, our average annual discharge looking to be about 3,200 cubic feet per second. We fast forward through time, and this black line, this is a line of best fit to show the basic average of increase, and it just goes up and up and up and up and up. And lo and behold, about modern day here, I think I did this chart around 2016, but the point still stands. We've seen a pretty substantial increase in our average annual discharge volume of water from the Maumee River system. It's just about doubled, roughly. And you can look at this on charts and think, well, it's a chart, we have a trend increasing on a chart. Is this something we can really see across the landscape? And yes, we can see it across the landscape. So I'm going to switch watersheds here and show you a really cool example of what this increased water volume does. So we're going to switch over to the Sandusky Watershed. Sandusky Watershed has a very similar history that matches the Maumee River. It has also seen a dramatic increase in water volume discharge over the last century. And it drains, out Sandusky Bay into Lake Erie. So this is an image of Sandusky Bay, what it looked like in 1926. And I have to put a plug in for the Winus Point Hunt Club. That is the oldest duck hunting club in the United States. And the owners, even back in the 1920s, were beginning to realize that, hey, something's changing in the landscape. And they had the foresight to get aerial photography of Sandusky Bay to track the changes. And it's really fortunate today that we have this. So this is Sandusky Bay, 1926. Take a good look at this. So when we're out in the bay itself, you may notice there are these little black dots out in the main body of the bay. Those are vegetation mats. You've got a fairly substantial island over where Muddy Creek Bay currently is. And even on the south side of Sandusky Bay, you've got these river systems flowing into Sandusky Bay. So it's quite a bit different. Here on this point, this is where the city of Sandusky is now. And you can see all this black stuff here in the image. That's all vegetation, wetland complexes, those kinds of things. Where you've got fields starting to get squared up, that's where folks are coming in, draining, and starting to farm. So this is Sandusky Bay, 1926. This is the modern image of Sandusky Bay that anybody can pull up from Google Earth. Looks pretty different. You don't see those river systems. And so now the next slide, what I'll show you is an overlay of modern day Sandusky Bay with 1926 Sandusky Bay. And I just outlined the margin of Sandusky Bay to help it stand out a little bit better. And this is what the images look like. And what's really incredible is you notice, those river systems in the south, they're gone. You could not tell based on a modern Google Earth image that they were even there. Also, this red outline that we have, this is all open water. So from 1926 to now, Sandusky Bay's volume of open water has greatly increased. And we also don't see the vegetation in it anymore like we used to, because it's gotten a lot deeper and it's just got a lot more sediment in it. And we've got islands and even old breakwalls that have just disappeared underwater in Sandusky Bay. So we look at these discharge changes in our rivers where we have good historic aerial imagery. We can really see that those changes in the watershed, they alter the landscape a lot. And also where we have increased discharge of water, we also have increased volume of nutrients being transported. So if you're a data nerd like I am, and you would ever like to keep up with what we know about nutrient transport in the Western Lake Erie Basin, I highly recommend you go and Google the Lake Erie Harmful Algal Bloom Forecast or the Lake Erie HAB Bulletin, and you can get a report like this one here on the screen emailed to you during the bloom monitoring season, which starts basically from March and runs until about August and September. And it's just, you can even go and get these bulletins that kind of aggregate some of the data over multiple years, which is what this one kind of shows. So we've got this bar graph in here, and it shows the severity of the bloom of the Western Lake Erie Basin. It's different every year, and that's different every year because our phosphorus loads are always different every year. And our phosphorus loads are driven largely by rain events and flooding events from the rivers. But the nice thing is, since we've got expertise from folks like at the Heidelberg National Water Quality Lab, they come and they measure the amount of phosphorus coming out of the Maumee River every day, 365. So we have a very complete data set to estimate the total metric tonnage of phosphorus coming down the river. And by having that really precise data, we are able to generate reports like this to forecast and estimate, well, this is how bad the bloom may be based on the amount of phosphorus that came down the Maumee River. Or this is how small the bloom is going to be, because we didn't have a lot of phosphorus come through as we had drought. So believe it or not, there is a good data set that supports the relevance of storm events and flood events to phosphorus transport. So this is a very busy slide. So let me walk you through it, but it really helps you understand the dynamics of what we have to do to try to reduce phosphorus going to the Western Lake Erie Basin. So we have two different figures here. Both figures are looking at dissolved reactive phosphorus, this little beaker in the center here. That's what dissolved reactive phosphorus looks like. Notice how the fluid in that beaker is perfectly clear. There is no visual indication to tell in a water sample if it's loaded with dissolved reactive phosphorus or not, because this is phosphorus that's perfectly dissolved in water. It's not attached to any kind of soil particulate. And we always look at this level of phosphorus because it is 100% bioavailable to feed a harmful algal bloom in the Lake Erie Basin. So that's our nutrient we're looking at here. On one side, the side with the yellow dots, this represents data from the Maumee River system. The side with the red dots, this is data from the Cuyahoga River system. So the Cuyahoga, that's a watershed that's very heavily impacted with urban activity. And a lot of their phosphorus that discharges is largely from water treatment plants, wastewater treatment plants primarily. And so let's go down here, we'll break down the graph. On our x-axis, again, we've got months, we've got time, and this is just the 2013 water year. And we've got these blue peaks in here. The blue peaks represent the volume of water flowing down the river at that period of time. And then we've got our red dots representing the concentrations of dissolved reactive phosphorus. And one thing we can notice, so we'll start over here in April for the Cuyahoga River. We have a flood event. We've got our blue spike here. But when the river spikes up from the flood, we notice that dissolved phosphorus concentrations actually decrease. So here again, we had another big spike between July and August where the river flooded and our dissolved reactive phosphorus levels decreased. And that really shows that dissolved reactive phosphorus is coming from a point source. It's coming from a wastewater treatment plant that is largely discharging the same volume of dissolved reactive phosphorus every day. And this is a case where the solution to pollution is dilution. Now, if we switch over to the Maumee side is very different, tells an entirely different story. So between April and May, we see a big flood spike represented in this blue peak here. As the floodwaters increase, we notice that our concentration of dissolved reactive phosphorus also increases. So really, when we're talking about nutrients and phosphorus moving across the Maumee River watershed, it is moving across the entire landscape. This is including our agricultural working lands, as well as all of our urban lands. So when it rains and the river floods, that's when we're seeing a lot of our phosphorus transport. So if you notice, in some years, we don't have a very big bloom in Lake Erie. We'll still get a bloom, but it won't be like a 2014 level bloom where it's just enormous. We oftentimes get those reduced blooms because we had droughts and we did not see big floods that moved a lot of phosphorus. So it's a pretty important thing to keep in mind. Also, in case you're wondering why this x-axis only extends from April to August, that's because of how water moves through our rivers and out through the entirety of Lake Erie. Nutrients that move during this spring into summer time period, those are the nutrients that will be available to feed a harmful algal bloom. We're not really interested in nutrients that move in, like November, because if we get a flush of nutrients in the Western Lake Erie Basin in November, the water's cold, the algae is not going to be growing, and more likely than not, that body of water will have moved, clear out of Lake Erie and will not be in the position to feed an algal bloom when the water's warm. Other important thing to keep in mind when we talk about water quality problems in the Western Lake Erie Basin is that our rain events have changed. So this is not modeled data. This is actual measured data. So this chart that has the light turquoise green on it, this represents average annual precipitation from about 1981 to the year 2000. So most of the Maumee River watershed would have experienced about 800 to 900 millimeters of precipitation every year. So we fast forward in time and look at the same measured data from about 2001 to 2017, and you can see the Maumee River watershed in this image. It's much darker. We've got more dark blues and even some purples, showing that average annual precipitation across this watershed is increasing over time. That is what the trend is. And this is just average annual precipitation. It doesn't take into an account that we've also seen trends in increased severity of storm events. And these are all important things to keep in mind, because as our severity in storms increase, as our precipitation increases, it ups the discharge at rivers like the Maumee. And as we saw from the previous graphic, the more floods we have, the more transport of dissolved reactive phosphorus we have, feeding a harmful algal bloom. And what is this all about? It's all about this. So this is a nice graphic. I like to just show people to serve as a reminder. This is why we're doing this work and why all this data is important, because we want to try to prevent issues like this. This is actually a harmful algal bloom, a microcystis bloom that formed in the Maumee River at Toledo in 2017. All right, that's a lot of doom and gloom. Here's the happy part of the presentation. What are we doing at H2Ohio to help address some of these issues? So major things we know we need to do: we want to capture heavy storm events, we want to try to address subsurface drainage, and we want to try to use wetlands as a filter to try to buffer the Maumee River watershed so it doesn't experience such violent flood events. So this is a nice project example. This is an H2Ohio project that we are working on in Allen County with the Allen County drainage engineer. So believe it or not, when we have folks that are willing to think differently about wetlands, wetlands can be used to solve some flooding problems, which is exactly what this project intends to do. So there's quite a bit going on here. So this red dashed line here on the map, that encompasses a watershed area. It's about a 500-acre sub-watershed. This is a project just north of Lima. And what we can see here, this is kind of the outlet end of the watershed here. This is a community, this is a low-income community that has been experiencing pretty severe flood problems every time it rains. And Allen County has been getting hit with increased severe storm events. So this is a project where what's proposed is we're going to install about 17 acres of wetlands to help improve water quality, as well as to detain floodwaters from these storm events. So if you look at these polygons, I've got these 3 polygons inside the watershed. These are all proposed wetlands that are going to capture stormwater flows and hold them so the water doesn't just rush across this watershed and flood this community. You'll also notice we've got these yellow lines here throughout this project and this blue line here. We're actually going to use a subsurface drainage network to help capture water that will fall on this community. And this drainage network will then route the water to the wetlands for additional treatment. So it's a unique concept. Rather than just using tile to push water off the landscape, the nearest ditch, and move it away as fast as we can, we're actually going to use subsurface drainage, the subsurface drainage network, to fill our wetlands with stormwater flows and retain it. So that way, after the storm passes, we can have a very gradual release of water from these wetland systems, and the vegetation will have an opportunity to take up excess nutrients. It's a pretty cool project. And I'm happy to say that since we've started with this one, we're getting a few more projects like this. So it's going to have a great water quality benefit and also should have a positive immediate impact for this community. Here's another one of our projects done by the Great Black Swamp Conservancy. And this is done in Sandusky County along the Sandusky River. And this was a really excellent floodplain wetland restoration. So if anybody's driven through Fremont lately and you've taken the State Route 6 bypass over the Sandusky River, you've probably driven past this project. We actually have a little H2Ohio sign right here on the westbound side of the highway, right along this northern field of the project. And this is really neat. This was 94 acres of bottomland farm field that the Black Swamp Conservancy was able to purchase in 2014 using funding from the Land and Water Conservation Fund, which is a great tool we have available here at the state to preserve public lands. And so they had purchased this and have been holding on to it, and we're really looking for a tool to come about to restore this property into the floodplain wetland that it wanted to be. H2Ohio came about in 2019, and this became one of our projects. So for about $1 million, we were able to come in and do this fantastic restoration with biohabitats. So that was our contractor that did the job. And they restored this wetland. So what was really neat on this site, along the margin of the Sandusky River, there used to be lots of diking to try to limit the amount of floodplain flow that would come into the field and drown out crops. So a lot of that diking was removed. There were additional excavations that were done to help the river access this area. And this is a really weird site. You know, the river flows from south, the bottom of the picture, north, and moving through the main body of the picture. But this field actually backfloods. So the Sandusky, the lowest point is up here, and the river, when it gets high enough, will backflood this site. So the site will flood from north to south. So it's pretty cool. I'm really glad we invested in the engineering to figure that out, because that's not generally how most river floodplains flood. Now it's neat here. You can see there about these 3 graded areas, and the contractors did come through and lower an area here near the bridge, and they lowered another area here. So that when we do get a large flood event, I mean, this was a good flood event, but it wasn't it wasn't a dangerous flood in the Sandusky River. But if we ever did get larger flooding events, the river will be able to come up these pathways and have additional means to further inundate the site, which is what we want. That's what the purpose of floodplains are. When rivers flood, that's where the water should go. So we're really excited to get this one restored. Has great sediment and nutrient reduction value. All right, here's another example of an H2Ohio project. This is our fruit project that was done in Seneca County. So here's a nice pre-construction image of the wetland. And then here's the post-construction. And I have to brag, this was our very first H2Ohio project to ever get done. And it was completed in less than a year. I think we signed the grant agreements on January 2020. And the project was completed, and our director, Mary Mertz at DNR, did a walkthrough of it in July of 2020. So very first project we got done, turned out really nice. And then this is another project that really shows the value of how we're placing these wetlands. So Here in the upper right-hand corner of the slide, this is the conceptual restoration design that they were using to show that, okay, there's a tile coming in here, there's a tile coming in from this other direction, it's flowing through a restored stream through the site, it's going through these 3 restored wetlands areas, and then eventually flowing out south to the St. Joseph River. And we've got a nice aerial image. The project was still in construction last winter at this time. This is an image from March of 2020. We've got this one done. I'm sorry, March 2021. And what's really neat about this site, so we've got a big wetland complex back here. There's a wetland in the center now. There are wetlands on this lower area. This is all floodplain of the St. Joseph River. But this is a site where we left subsurface drainage tiles intact at the north end of the property. I mean, these tiles are huge. They're 12-inch clay tile. And what we're doing, we left that tile intact because we can actually capture subsurface agricultural drainage from about 300 acres worth of surrounding farm fields, which is exactly what we want to try to be able to accomplish with these H2Ohio projects. So this was a 95-acre parcel that was purchased. We got 35 acres of wetland.
Okay, I think I lost connection for a moment.
Okay. I was just looking at the chat and seeing if we had questions, and I think we do. One question here, with so many acres restored, what is the strategy for managing invasive species? That is an excellent question. So what I can say for a lot of the projects, for preliminary establishments, we had a lot of grant awardees that we budgeted 2 years of invasive plant management for some of those projects, like the Red Horse Bend project I showed you. Here, I'll just go back to it. So like for the Red Horse Bend project here, that's a big project. We already have pre-agreed to with a contractor, and Black Swamp worked with them to have 2 years worth of invasive plant treatment. For our private lands wetlands, they have to manage invasive species through their Lake Erie CREP agreements. So they are concerned, we are aware of it. A lot of our projects are prepared to address invasive species, especially in the early establishment of the projects. So, oh no, John said he wasn't getting any sound. Oops. Let's see, other chat question. Are you constructing any wetlands for phosphorus export and not just retention? Example, harvesting biomass and compost. No, we are not really looking at constructing any wetlands for export of phosphorus. Just that's going to require more manpower than we have. So a lot of our projects are set up to catch phosphorus and hold it passively. For harvesting phosphorus, there are some edge of field wetlands we're considering in agricultural landscapes. So there's a project I've been working with the Ohio State University on where they have a subsurface drainage network that is taking agricultural drainage and shunting it to some wetland acres. And so that may be one where maybe that can kind of function as phosphorus harvesting. I'm not sure. I mean, yeah, for a lot of our wetlands, they're set up to just really detain phosphorus. They're not set up for us to like go harvest vegetation and then take the vegetation off to go and, you know, have it spread somewhere else. But I know ODA has played with that application for some of their working lands. Like they actually have buffer strips that can be installed. And the idea is you get permanent cover that can absorb the nutrients, and then the vegetation is cut off and taken off site. So ideally you're exporting nutrients from that system. So I think that's all the questions I had, unless there are any others.
Yeah, so it looks like it maybe froze up overall, Christina,
Oh,
when you were
no.
wrapping up. So I don't know if there were any closing, like before, when I could see and hear again, it was just your end slide. So I don't know
Oh,
if
no.
there's anything we might have missed, but if not, I was wondering about the monitoring.
Yeah.
Is it based on each site, or do you have kind of like an overall monitoring plan that you hope to follow, like a number of years or specific things that you're going to look at?
Yeah, there is an overall monitoring plan. So we really gave the Learn Consortium the ultimate challenge, because we have floodplain restoration projects like the Red Horse Bend project. And then we've got projects. This is more of an upland wetland project with the Fruth restoration. It captures some water from these fields, but it actually captures surface runoff. And then we have a wetland that's different, like this. So they're all different types. And I didn't even talk about any of the coastal wetland restoration projects where we were taking existing coastal wetlands and basically retrofitting them to take on agricultural drainage and also take on water from Lake Erie itself. So we've got 4 main different project types. And what the Learn Group has done, they're trying to roughly categorize all of our project types and develop means and methods to go, and they will intensively monitor several of the projects, and then they will more remotely monitor others. But it's been a big issue to try to figure out, all right, we've got so many different projects, how are we going to be able to compare them apples to apples? So they've been standardizing all the methodology to make sure everybody's running the same kind of dissolved reactive phosphorus measurement. Everybody's looking at the same kind of soil data. It's been a huge undertaking. So what they've done, they've basically developed a standardized document to standardize the methods across all the projects. And then actually this week at Maumee Bay State Park, well, it was going to be at Maumee Bay State Park. We were going to have an in-person meeting, and that got moved virtual because of COVID. But the Learn Group is actually sitting down with all the research teams and the water quality teams to try to, you know, get in the details of every project to make sure they're capturing every detail so we can have the best picture of how well they reduced sediment and nutrients. It's a huge experiment that is on a massive scale that no other state has ever done. It's truly unprecedented. And even though there's a lot going on with H2Ohio and some days are kind of frantic, so there's so much to get done, this is by far and away one of the coolest things I've ever been able to do in my career. It's unprecedented. It is absolutely unprecedented. So yeah, I'm looking through some more of the comments. from Maryland Dufour, you were talking about the 300 acres of subsurface drainage from adjoining farm fields, the last project with the sound cut out. That's a bummer. Okay, Mel Reed, how much will this improve the water quality? Well, right now with a lot of our projects, we're probably going to see water quality improvements on a very localized scale. Because ultimately for water quality improvement to happen in the Western Lake Erie Basin, it's going to take a long time. It took probably 100 years to really efficiently drain the Great Black Swamp. And so all of these projects are contributing towards that positive improvement. And again, that's why we're really excited to see what the data from the Learn Group is going to churn up, because if some projects are able to reduce nutrients more so than others, that's what we're going to go after. And we do have a modeled approach for estimating the amount of phosphorus that these projects will reduce. I can't recall what the estimate was, but you can follow up with me if you'd like, and I can get that estimate from Eric Sauce, our H2Ohio coordinator. Let's see, from Eric, is there any work like H2Ohio being done in Southeast Michigan or adjacent parts of Ontario? I've talked with some folks in Ontario, that was in 2018. I'm not sure where they're at right now, but there was a focus then where they were trying to work with private landowners to install more water quality practices on private land. We have talked to some of the teams in Michigan that are doing water quality projects. They are interested in some of the work that we have done. But again, I have not heard that any of it is to the scale that we are really looking to do in Ohio. Let's see, another question. Are any of the restorations multi-use, like wild food crops, thinking about elderberry and other wetland plants that can also produce food? You know, that hasn't come up. We haven't really talked about that. It'd be something to consider. If someone wants to put a project our way for wild food crops, I'm all for it. I know this particular project I have right here, this is the St. Joseph Floodplain Wetland Restoration. This project was part of Black Swamp Conservancy's Food and Farm Initiative, and we actually worked with Black Swamp to cut out a few acres at the top right along the road so that it could be sustainably farmed. So I think there was someone coming in to grow organic alfalfa, something to help young farmers that are interested in contributing towards the agricultural economy but have difficulty renting farm ground. So this was one of those projects. Let's see. Okay, another question. Since Ohio is second only to California in loss of wetlands, it's wonderful to see that we are now working to restore. Yep. Well, thank you all for your very positive comments. Thanks for the good questions as well. Thank you, Brenda, for the compliment on my delivery. I really am looking forward to seeing people in person again, because it is kind of strange for me to be here in my office and I'm talking to my screen. It makes it a little challenging, but I appreciate you all. I appreciate your positive feedback and your good questions.
Thank you so much, Christina. We really appreciated your talk and your time. And I agree. I understand exactly what you mean when you're trying to give a presentation and all you're looking at the screen. It's kind of funky. But yeah, thank you so much. We really appreciate it. It was a great presentation.
Cool.
Just to let everybody know, we do have a member Q&A coming up in March. So if you have any questions about native plant gardening that we can help you with, please feel free to submit those questions to our Wild Ones Gmail. And we will be happy to address those at our meeting in March. And other than that, that is all we have for tonight. So thanks everyone so much for joining us. And thanks to our program committee chaired by Sarah for getting this, getting our programs organized. And we will see you all next month, I hope. Thank you. Bye.
Take care all.